Okay, we're going to talk about velocity time graphs. We're doing Chapter 13, Introduction. So, a velocity time graph is when you have the y-axis is the velocity and the x-axis is time. So in this example, we have the velocity is kilometers per hour and the time is just in hours. So if we think about this uh, if we think about, so let's just stop for a second. If I was going 1 hour at a velocity of 8 kilometers per hour, how far would I have gone? You're right. If I went 1 hour at a constant velocity of 8 kilometers per hour, I would go 8 kilometers, right? So, what we notice when we have uh, our y value and our x value is if I do length times width, the units, hours and kilometers per hour, the hours cancel out and we're left with the area under the graph gives us the distance. Because if this unit is in hours and this is in kilometers per hour, we're left when our simplified uh, equation or our simplified answer is left in distance. Now, in class, we talked about this. So I could break this up into two pieces. I could break it up into a rectangle. I could break it up into a triangle. And so if I wanted to know how far I went in this blue rectangle, well, in the blue rectangle, I've gone 4 hours at a speed of 8 kilometers an hour. So if I multiply 8 kilometers an hour times 4 hours, I've gone 32 kilometers. Okay. If I look at the green rectangle, it makes a triangle. And we know the area of a triangle is 1/2 base times height. So this base, the distance from here to here is 2. And this height here is 8. So I've got 2 hours, sorry, and this height here is 8 kilometers per hour. So we multiply this times this times this, and we end up with 8 kilometers. So then we multiply, or we add the 32 kilometers and the 8 kilometers together, and we have 40 kilometers for the distance traveled under this diagram. Okay, so the important thing for reflection is that the area of the graph gives you distance when you've got a velocity time thing. So this highlighted part is the thing you should copy here. Okay, so an important geometry formula that we need to focus on is the area of a trapezoid. So the area of a trapezoid is when you've got 1/2 base 1 plus the base 2 times the height. Okay, so now the bases have to be parallel. I can't use this one here and that slanted one here. Those aren't not the bases. It has to be the ones that are parallel. So here's base 1, base 2. Okay, so the formula for finding the area of a trapezoid is 1/2 the bases added together and times the height, the distance between the two bases. So in this example here, we have 1/2 5 plus 7 and then times 3. That gives me an area of 18 centimeters cubed. Here we've got pi r squared with a radius of 3, but this is half of a sphere, so we have to have our answer divided by 2. You may hit pause if you need to. Okay, now the next part, example 1, for the velocity time graph, find the distance traveled. So we've got this formula Vt equals negative 5t plus 10. Okay, so to figure out this time here, this blue one, when time is 0, we're here on the y-axis here. So if I plug in 0 in for the time, I end up with -5 times 0 plus 10. So I know that the y-intercept when x is 0, or when t is 0, is going to be 10. So this coordinate is going to be 0, 10. And here, now if I make vt equal to 0, that means the height here is 0. Then I could say 0 equals -5t plus 10. So we could add 5t on both sides, divide by 5, and we get 2. So this coordinate here is uh, 2, 0. Okay. When t is 2, v of t, or the y value, is going to give me 0. Okay, so now that I've got these coordinates here, I can find the area. So this distance from here to here is my base, 2. And let's pick a color. Or, let's see. This is a fine color. So my height here is 10. My base there is 2. And so 1/2 base times height, area of a triangle, we end up with the area is 10. Okay, and this is meters per second and times seconds, so this is 10 meters is the distance. Okay. Now, the next one, so same thing. We've got this equation, y equals 1.5t. So when y is 3 at this height, because we know this goes across here, right? So when the y value is 3, we can figure out what x is going to be. So 1.5x equals 3. Divide both sides by 1.5. We know x is going to be 2. So right this point right here is going to give me a value of 2. Okay, this is a value of 2. And the height of the triangle, we know that this height from here to here is 3. So to find the area of this triangle, it's 1/2 base times height, 1/2 2 times 3, which is going to give me an area of 3. Now this rectangle has a height of 3, and it's got a base, a width of 3. So the area of the actually square, not a rectangle, is going to be 9. So we add these together and we get 12. Now I could use the trapezoid formula also. We know my base is 3 and this base here is 5. We know this height is 3, and so 5 plus 3 is 8. Multiply those all together and you get the area is 12 also. So both formulas, both ways of thinking will get you the area. I could either find the area of the triangle plus the area of the square added together, or I could use the trapezoid formula. We're going to be using the trapezoid formula quite a bit this chapter. Okay, so base 1 is 60, base 2 is 30. The height from here to here is 50. This base is 5, this base is 11. The distance between here and here is 3. Same process as the previous one. When the y value here, v of t, is equal to 0 right here, we can say, okay, well, v of t is going to be 0, so 0 equals t minus 1. So if we add 1 on both sides, we get t is 1. So when t is 1, v is going to be 0. So this coordinate is 1, 0, right? Now, over here, if t is 4, then I plug it into the equation. 4 minus 1, I get 3. So this height here is going to be 3, because this coordinate here is, this is 4, 3. 4, 3. So the height from here to here is 3. The distance from here to there is 4. But if this is 1, then from here to there has to be 3 if that's 1. Okay. Lastly, we have a piecewise function. So the first part right here is the equation y equals x. The second part of the equation is y equals 5. So if I have y equals x, so for every whatever x is, if x is 1, y is 1. If x is 2, y is 2. If x is 4, y is 4. And you end up with this orange line. Over here, y equals 5 gives me a horizontal line at 5. Okay, so so what is this area? 4 plus 9, and then add those together, divide by 2, multiply by 5, and there is our area.